All right, so we were talking about using inverse matrices to solve matrix equations. You need to have your book open to page 210 now, and our second application of inverse matrices is we are going to use them to solve systems of equations. And if you remember way back in the fall, in chapter 3 was all about solving systems of equations. And we solved them graphically. And we solved them by substitution. And we solved them by elimination. And so this is a fourth way to solve a system of equations. And remember that a system of equations is basically that x and y, or that x, y, z, that make both equations true at the same time. And so if you look on page 210, you will see the system x plus 2y equals 5, and 3x plus 5y is equal to 14. And so again, this looks like something just right out of chapter 3, and we could solve it graphically or by substitution or elimination, but we're going to use inverse matrices. So the first thing we have to do is turn the system of equations into a matrix equation. And so we know that there's an understood 1 in front of the x, and so what we're going to do is we are going to create a coefficient matrix, which will contain the coefficients of our variables. And we don't need to write the variables, so we're just going to use the 1, the 2, the 3, and the 5, our coefficients from here. And we're going to take x and y, and we are going to stack them, and this is our variable matrix. And then we're going to have our equal sign, and then the 5 and the 14 make up our constant matrix. And then it looks very, very similar to the problems in our other video, only instead of just a big X right here, we have X and Y. And one of the really neat things is if you were to multiply these together, multiply the row and the column, 1 times X is 1X, and then we would add to that 2 times Y, and we would get this equation back right here. And then 3 times X plus 5 times Y would go right here. So now our directions, again, are to solve the system. And so we have matrix equation, just like we just worked on in our first video. So I need to take the inverse of our 1, 2, 3, 5 matrix. And so I'm going to have 1 over. So again, I'm working on finding the inverse of our coefficient matrix. And so we are going to have 1 times 5 minus 2 times 3 underneath the 1. On the inside, we are going to flip the 1 and the 5, and we're going to change the signs on the 2 and the 3. And on the outside, we have 5 minus 6. So we're going to get negative 1 over 1. And so when I distribute that through, my inverse matrix is going to be negative 5, positive 2, positive 3, and negative 1. So our inverse matrix is negative 5, 2, 3, negative 1. Now I'm going to take that inverse and I'm going to multiply it in front of the constant matrix, just like we did just a few minutes ago in our other video. And we're going to multiply these together. We're going to take negative 5 times 5 plus 2 times 14, and then 3 times 5 plus negative 1 times 14. And so I get negative 25 plus 28, and so I'm getting 3. And here I'm getting 15 minus 14 is 1. And so our variable matrix, xy, is going to equal 3, 1. So that means that the point 3, 1, when x is 3 and y is 1, that would be the solution to the system. That means that if we took these two equations and we graphed them, they would intersect at the point 3, 1. If we took these two equations and we used substitution or we used elimination, our answer would be 3, 1. So inverse matrices is just another way of solving systems. And in pre-cal, we will use it to solve larger systems, those big 3. This way can be a little bit faster. Now, before I let you go, I would like for you to try on page 211. There is a check understanding number 2. So check understanding number 2, and I would like for you to try part A. So we have 5A plus 3B equals 7. 3A plus 2B equals 5. So I'd like for you to pause the video and see if you can solve the system using inverse matrices, and then turn the video back on and check your work. And so our coefficient matrix would be 5, 3, 3, 2. Our variable matrix is A, B. Our constant matrix is 7, 5. So we would take the inverse of our coefficient matrix. So I'm going to have 1 over 5 times 2 minus 3 times 3 on the outside. On the inside, the 2 and 5 trade places. The 3's change signs. So here I've got 10 minus 9. So on the outside, I've got 1 over 1. So when I distribute the scalar, nothing is going to change here. So my inverse matrix is 2, negative 3, negative 3, 5. I'm going to take that and multiply it in front. Remember, order is important, and you wouldn't even be able to multiply it if you reverse the order, because this is a 2 by 2 and this is a 2 by 1. If you reverse it, they won't multiply together. So we're going to multiply our row by column. So we're going to have 2 times 7 plus negative 3 times 5, and negative 3 times 7 plus 5 times 5. And so I get 14 and negative 15 gives me a negative 1. Here I've got negative 21 and 25 gives me a positive 4. So A and B are equal to negative 1 and 4. So remember that with ordered pairs, we put them in alphabetical order. And so the solution to the system is negative 1 and 4. Negative 1 and 4. Now, just a reminder that tomorrow we will have a quiz over finding inverse matrices and over using them to solve. If you have any questions, remember that we will be having our Zoom session at 9:30 on Wednesday, and you can come in and ask me your questions, and I'll be glad to answer them. At 10 o'clock, I will open the quiz. And remember that for your quiz, make sure that you take very clear pictures and that you email them to me. And then for your Schoology assignment, or where it says assessment, just go ahead and say I emailed them. And so just, again, please clear pictures and email them to me. All right, your homework for your uses of matrices in your book on page 199, I want you to work 22, 24, 42, and 48. And on page 213, I want you to work number 1, 4, 7, 10, 11, and 12, and 37. So 1, 4, 7, 10, 11, 12, and 37. And the first 2 problems you don't even have to solve, just follow the directions, and they just want you to write the matrix equation and then do some identifying. And this assignment will be in Schoology as well. And again, send me your pictures and quiz tomorrow.